All right, it looks like we're live. So, Chris, thanks for taking the time to come on and being willing to have a conversation with me. I really appreciate you taking the time out of your day. Would you like to tell us a little bit about yourself and your channel before we get started?
Uh, um, Catholic. I talk about all sorts of things on my channel. Um, uh, Sorry, it's been a little bit of a long day. Um, wasn't prepared to talk about myself. Um, yeah, I talk about all sorts of things from um, philosophy, epistemology to just life skills, learning about things, learning about what stuff means. So all sorts of stuff.
You run the Missing the Mark channel, correct?
Correct.
You're also an author, is that true?
Mm-hmm. Yeah, I've written a few novels.
That's pretty cool.
Thanks. It's a lot of work, but it's fun.
All right, so just to jump right in, I am an atheist, by which I mean I don't believe there's any reasons to believe in the existence of a God. Could you tell me some of the reasons you believe there are for a belief in a God? Then I'd like to tell you my position on those reasons. Then I'd like to hear your thoughts on my position.
Sure. Um, the Let me see. Well, actually, let me just ask first, because the thing is, literally everything is a reason to believe in God, and there are a lot of different ways to see, for the different things that they are, and different people appreciate different aspects. So let me ask the question, just to have a sense of sort of where you're coming from, because I could go in a bunch of different directions with this. What is of the arguments you've heard for God? Which would you say is the best?
Probably
Just subjectively.
probably the contingency argument. I believe that there must be some necessary foundation of everything, but I don't think there's anything that indicates it's a God as opposed to any of the alternatives like a deism or polytheism or transtheism or my favorite naturalistic pantheism. So I don't think, even though I do grant that is a good solid argument, I don't think it indicates a God over the non-God alternatives.
Interesting. Okay, that's actually somewhat atypical. The more philosophical um, arguments. Interesting. Okay, so that gives me a sense of where to focus. Um, okay, so you see, actually, argument from contingency and necessity. Well, actually, in that case, um, if essentially, well, okay, so if that's the one, then I think the place to go is to talk about the where that leads to with the aspects of God. But let's um, actually, if you don't mind, I'll run through both the argument from motion as well as the argument from contingency and necessity, because the two of them together actually then go on to tell you a bunch of things about the nature of God. Um, that's one of the unfortunate things in a lot of internet discussions. Roughly speaking, I'm looking at where I have my copy of the Summa Theologica. The basically people stop at the question whether or not there's a God, and then neglect the next 30 some odd pages, which then develops this idea. So if we look at the argument from motion, which is generally misunderstood because the term motion has changed. Unfortunately, as stuff is translated to English a long time ago, when motion meant just change. And unfortunately, motion has come to mean local motion, change in location. So the argument for motion has tended to mean, the argument from the argument from
Physical motion, right?
yeah, from like the thing changing place. And unfortunately, then it gets understood to mean what is, so like if I throw that, throw the coin, it was where did the motion come from? It was the throwing. That's not what the argument for motion is about. It's not about a sequence of things within time. It's rather about how does anything change at all? Because you first have to look at what is change. Now, change is the coming into being of something or the departing from being of something, right?
Well, I would. That's one interpretation of what change is. There are many different interpretations. For example, Hume's rejection of causation, or the B theory of time, which says that all things exist simultaneously, and change is just periphery or ephemeral kind of appearance that doesn't actually exist. So I'm not actually sure we have a solution for what change actually is fundamentally. We just have interpretations.
Okay. The B theory of time, it suffers from the problem of being sort of obviously false. What with us like observing time. So What's really annoying is that the B theory of time actually does borrow from something that's kind of true because God is outside of time, and so it's describing God, not us. Um, so okay, so if you're going to say you don't know what change is, it's then not possible really to talk about what change is. Um, okay, so and this also actually, so if you're also going to say you don't know whether or not time exists, which is an accurate description of what you just said.
Oh, well, I do believe time exists. It's the question of what time is the thing we can't really be certain about. So, for example, there are the current theories in physics is that time and space are emergent from some more fundamental natural property. So, time and space are not fundamental; they're just subsidiary properties of something else that we just don't know about yet. That would be like Nima Arkani-Hamad's emergent spacetime theory, which is from his paper, The Amplituhedron, and Sean Carroll's emergent spacetime theory. Those are the two that I'm most familiar with. So there are many different kinds of theories about time. For example, there's the two-time physics from Itzel Bars and imaginary time from Stephen Hawking, where there's multiple dimensions of time, different kinds of time. And Julian Barber's The End of Time. There's a bunch of different theories about what time is. Again, we just don't know exactly what it is. We do know it exists, but how it exists is kind of the unknown.
Okay, so let's see. So, well, okay, one problem with saying that there exists a physical theory or a theory in physics is I'm just thinking of how to be polite about it. But roughly
No, don't
speaking,
worry about it. Don't worry about it. I can take the insult.
well, no, it's not about you, but about people not, metaphorically speaking in the room. The problem that there exists a theory in physics is saying that there is somebody, roughly speaking, there is somebody who has proposed some set of equations as possibly describing reality.
Right.
That's not saying very much. I mean, literally anyone can write down equations and then say these could describe reality. And this is sort of one of the problems within theoretical physics is that there are several different ones. As I can't help but remember, actually, a physicist friend of mine, he's an experimental physicist, and one of his big complaints is that a lot of the theories suffer from being completely and thoroughly untestable. As he said, you've seen some theories where like you would have to construct an entirely new universe within your lab, and he doesn't have the budget for that.
Right.
Was the way he put it. But the problem with that is when you get to things which are completely and thoroughly untestable, and you see this, all sorts of string theories suffer from the exact same problem, right? They postulate anywhere from 6 to 40 some odd dimensions. That the problem is, of course, since we don't observe any of these things in any way, shape, or form, there's absolutely no evidence for such an idea. And more than that, there's sort of the related problem of the nature of a mathematical model versus reality. That a mathematical model is
Conceptual. It's made up in our heads. It's not necessarily something that exists.
well, it's almost necessarily not something that exists. I mean, the okay. Did you happen to see that the web comic Sunday morning breakfast cereal?
Maybe a long time ago. I don't really recall.
Yeah, it's kind of funny. Well, there's one really really great one that talks about the evolution of a researcher, and it begins with a researcher as a young person saying, "I don't care about these big questions. My job in life is to study these 621 badger neurons." And then the old researcher, then moved to the old researcher saying reality is at its core 621 badger neurons. And so you'll find any number of people who will these things become real to them in possibly depending on the particular theory and so on in much the same way that fictional characters become very real to people, in the same way that to some people Darth Vader is a real person and exists just as much as you or I do, or possibly to some people more than you or I do. And yet, Darth Vader isn't a real person, at least so far as we know. Possibly, in a galaxy far, long, long time ago in a galaxy far, far away. But so
Hey,
far as
maybe
we
in one
know,
of those like 13 dimensions of string theory, right?
Yeah. Um, so the nature of a mathematical model is different still, and you will find people who will more or less, frankly, in the manner of the 621 Badger neurons previously referenced, say that reality actually is mathematics, which I have never heard any way of making that a meaningful statement, as in a statement wherein the symbols within, within the grammar actually refer to something. Because the nature of mathematics is, at least of modern mathematics, it's a little different if you go to like Greek mathematics, like ancient Greek mathematics, like Platonic mathematics. But in modern mathematics, all mathematics is hypothetical. I have a degree in math. I spent a lot of time doing math, and all math is hypothetical. It begins with, suppose you have whatever, then it follows, and then you have a proof of whatever it is, the thing that follows. All mathematics is like that. It all begins with, suppose you have whatever. Suppose you have a number. The famous piano axiom. Suppose you have something. Suppose you have another thing. I'm sorry. Suppose you have something, call it one. Suppose you have another thing greater than one, call it two. Or, a successor to one, call it two. Suppose you have a successor to two, and so on. And then you begin to define, if you have these things, you can then define an operation called addition and move on. So all of this is conditional. There are different ways, but because you can again go to like the set theorists, who are sort of the wild men running naked in the bushes, but where they will do things differently. Instead of using, say, the piano axioms, they'll go for like the empty set and then the power set of the empty set and so on. You can actually define arithmetic this way. So there are different ways of getting at arithmetic.
Right, the Zermelo-Frankel choice.
It's been so many years. My memory's just blanking on which one that is.
Well, my initial question would be: is how is that different from the theologian's perspective? So we have this approach to describe reality, the fundamental nature of reality, and the mathematicians use math and say, well, this is what we're describing as reality. And the theologians are saying, well, we have this other method, which is usually philosophical arguments, and this is what's describing ultimate reality. From my perspective, the math is more supported since it's grounded. It's composed of things that are all empirically demonstrable, even if the composition itself is not empirically demonstrable, as opposed to the philosophical arguments, which none of which is empirically demonstrable. So,
well, mathematics is rather explicit. Modern mathematics, especially, is rather explicitly non-demonstrable.
Well, in physics, all of the equations, the principles, particles, and laws in the field of physics are things that are empirically demonstrable, combinations of things that are empirically demonstrable.
Yeah, but there are two problems. One, mathematics inherently isn't. Intrinsically is not. Mathematics always begins with, suppose you have X, and then argues for what follows. And mathematics always involves either completely abstract things, which you intrinsically cannot demonstrate, or it involves, it either involves intrinsically abstract things like numbers, or it, and again, I'm talking about modern mathematics, not Platonic mathematics, because the Platonists will argue that numbers actually really exist as transcendentals. But they're either abstract or it argues for necessary causation. Necessary relationships is the nature of it. Like to prove that the limit of something as limit of a sequence as n goes to infinity or something rather, is to state that for any epsilon greater than 0, there exists an m such that for all n greater than m, the sequence is within epsilon of the limit. I'm sorry if that's not familiar to you, then I did not state that clearly enough. Hopefully that's familiar to you as the definition of a limit. If not, I apologize. But that's the technical definition of a limit. If you are actually worked out how to prove like the limit of, like the limit of 1 over n as n goes to infinity is 0. Like the way you prove that that's the limit is that for all epsilon greater than 0, yada yada. Anyway, that's a statement about an infinite number of things. It is intrinsically impossible for us finite creatures to demonstrate that an infinite number of things applies. It's abstract reasoning. It holds that there is this necessary relationship of things. And, in that particular case, you would show for any epsilon greater than 0, you then...
Right. The math itself is abstract and doesn't refer to anything directly, but when we apply the math to things that are observable and testable, we can say, well, this thing that the math refers to is itself empirically verifiable, and then we can call that thing, for example, a particle or whatever, and then we have this empirically demonstrable aspect, which we can use the abstract math to refer to. And so all of the principles, particles, and laws that are used in physics are all of these things that are themselves empirically demonstrable, like all of the different particles, the spin, charm, the mass, energy, all of those different things are things that we can empirically demonstrate and make testable predictions about. And all of the different equations, the Feynman, Einstein, Bohr, Planck, Schrodinger, all of those different equations are things that have been demonstrated or have been able to be used to make testable predictions. And all the things used in physics are of that nature, just different combinations of those things. So they all have an empirical basis at their core, even if the different combinations themselves don't.
Yeah,
So,
the
for
physics
example,
does, the math doesn't. There's actually another problem, because if you're talking about quantum mechanics, they actually do mathematically invalid things in quantum mechanics. A long time ago, I had a girlfriend where she's both a math major and a physics major, and man, quantum drove her nuts, because they do things like divide both sides of an equation by infinity and just cancel the infinities and say, like, yeah, well, it works in practice, so hey, good enough, even though it's completely invalid. You're right that in physics you have empirically demonstrable things. Now that's physics, not mathematics, mind you, and you would start by talking about mathematics, not about physics. Um, Physics, of course, of its nature, studies empirically demonstrable things. It actually rather intrinsically limits itself to empirically demonstrable things, with the exception of things like string theory, which are completely untested. For which there is not, there's no string theory for which there's even a shred of evidence yet. But leaving out those as call them a weakness of fashion in human beings who are doing physics, if you want to, because lots of people believe in string theories despite there being literally no evidence for them. But so if we brush those aside and sort of concentrate on the part that is in fact demonstrably verifiable within physics, there actually is a very interesting sort of side note. Or, I'm sorry, not side note. An interesting point about what you said, though, about the nature of the demonstrations. And that is, almost none of them, once you get outside of Newtonian physics, like the macro physics, things like, the gas laws and, the pressure laws and basic thermodynamics and so on. Once you're getting into either super high energy stuff or super small stuff, all of this stuff is extremely indirect. So, like, are you familiar with the experiment that proves the electron exists? They're the one that historically did, anyway. The
no,
milk and oil drop experiment.
wasn't that the one for neutrinos?
No. The milk and oil drop experiment. That's the one where they suspended charged oil drops within a charged field.
Right. I think that was similar to the one they did for neutrinos, where they did the same thing with a different chemical and then had the neutrinos pass through, which then broke the chemical bond, created a new element.
I'm not familiar with that one, but I know it wasn't Milken because he was dead by then. But the one that proves. Do you know how the milk and oil drop experiment ran? The one that showed it both demonstrated the existence of the electron as well as came up with an approximate charge for the electron.
I do not familiar.
Okay, real simply, and then the reason to run through this is because it illustrates the point of what empirical verification actually means in practice. The way the milk and oil drop experiment goes is you spray a mist of fine oil drops, and then you have a charge plates which create a charge differential, and then you I forget all the steps, but let's elide all the steps anyway because we don't need to perform the experiment at the moment. But roughly speaking, most of the drops will fall down, but some of them will be just the right size with just the right charge. That in this field, the pressure of the charged field exactly equals the weight of gravity. And that suspends a few oil drops in place. You then observe, you pick the oil drop out, you then turn off the charged field, let the oil drop, you measure the rate at which it drops, then resuspend the field. You calculate its mass from that, from which you can then also calculate its charge. Because once you know the mass of the thing in the charge field, you can calculate because you have a known charge field, you can calculate the exact charge. Do this over and over and over and over and over and over again, writing down the charges of all of these things. And what emerges is that they are all a multiple of some base number. That base number is the charge of an electron and also shows you that charge comes in units, and that unit must therefore be the electron. So that's the empirical demonstration of the electron. This is how human beings, historically speaking, went from we don't know whether or not charge is quantized, and whether or not there is some elementary particle that has this sort of charge, to we know that there is this thing, we'll call it the electron, and it has approximately this charge. Now, as a demonstration, this is pretty far off from me demonstrating that, I'm holding a coin in my hand by going, here, see it. It requires essentially an argument. It requires the argument that if you look at all of these numbers for all of these things that I did, that they come down to, that they're all an integer times some base, I'm a programmer, so I think there's a floating point number, but times some base real or rational number. And because all of these oil drops, is the way I measured them within this field and so on, because, I can calculate their masses, and then if we know the mass we know based upon the charge and so on, we know that this was the total amount of charge on the oil drop. It actually was done first with water drops, but they evaporate too quickly. So that's why I switched to oil drops. But just a fun historical note. And you have to then argue, that the oil drops are stable, that the oil drops aren't, leaking oil and thus changing mass on you throughout the experiment. You know the water did. You also know, technically speaking, the oil does, but hopefully not enough to actually matter. So you have to then argue that there isn't enough, that the oil does not change, the oil drop does not change mass enough to matter. So the point being, this is demonstrable, but it's demonstrable at the end of an argument. That is to say, it requires an argument to show the conclusion. Quantum mechanical stuff is even more so, because all of this is very intermediated by machines. So everything you look at in modern physics, high energy physics and microphysics, outside of it, since these things are all intermediated by machines, they all require arguments about how the machines work and what it is that the machines actually show to you. So they are demonstratable in a sense, as long as you're willing to allow reasoned argument to be part of an empirical demonstration.
Right, which I am. Indirect observation is equally empirical as direct observation. For example, like if I said, what knocked over the cup, and we look at the cup, and we didn't actually see what knocked over the cup, we can make predictions and say, well, I believe it was a mouse, and if it was a mouse, we'll see mouse droppings around the cup, and if we discover mouse droppings around the cup, that's evidence to indicate that my explanation is correct, even if it's indirect, that we didn't see the mouse. So that's still good evidence. That's still, because it makes testable predictions prior to any other explanations, it's the best explanation we have at the time.
For mouse, yeah. I mean, lots and lots of things that knock over cups won't have any of those.
Right. That was just the first example that came to my head, but electrons are the same thing. When we make the calculations for what an electron is and what the charge is, it makes predictions about what the numbers we're going to get on the computer screen after we do the equations. And those predictions are consistently correct, more so than any of the alternative hypotheses that we have. And so it's good reason to believe that this explanation of electrons is correct, even if we can't prove it absolutely.
Okay. And that's fair. I'm not trying to claim that they're not. I'm only trying to make the point that reasoned inference and argument is an integral part of these things being empirically verifiable.
Oh, absolutely.
Now, I will point out, though, that it would be entirely possible, too, to come up with mathematics or physics models in which there aren't electrons, but there's something else.
Oh, yeah. Problem under determination. There's infinitely many you could come up with.
Yeah. Now, this is the same problem that that occurred a little bit ago when we were talking about time. That there are other theories of time. So, if there are other theories of an electron, basically, since you can have many, many theories of an electron that would produce these same results, it's very easy once you have numbers to then go back and fill it in. Which is, incidentally, the position that everybody's in with respect to time. With respect to time, we've all observed time, and then people are coming back and coming up with theories of it afterwards. Moreover, I'm having a hard time seeing at least what any of the testable predictions with regard to time is going to be.
Well, we have some in regards to general and special relativity and how time can bend with Lorentz length contractions, time contractions, and the relationship between how time and space bend in the curvature of light, and I forget what it's called. But the predictions Einstein made in gravitational waves, we have measured time as a physically existing thing, and those.
Well, time dilation, yes, but time dilation isn't the same thing as any, something like the D theory of time.
Right. So
So I mean, yeah, you're entirely correct that you have general relativity's time dilation, um, but that's not any of the theories of time as we were talking about it. That's essentially the relationship of time between various things. That's not the nature of time.
Well, right. We don't know what the nature of time is. We only know how it can interact in the way that we can make predictions, which as far as we can get is just general and special relativity for right now.
Well, and also that like things happen. I mean, the
Right.
predictions we rely on all the time is that the future is going to happen and things are going to change.
Right.
So the yeah, so like the B theory of time, for example. Well, I mean, what sort of prediction could the B theory of time make?
I have no idea. I'm not an expert on the B theory of time. I prefer the emergent space-time models. Those are my more interesting aspect.
Well, what sort of predictions could they make about time?
Well, they predict that you can demonstrate time is emergent from certain kinds of interactions, which is the things that are made in the paper, the amplitude-hedron paper by Nima Arkani-Hammad. It's actually a really popular paper, well cited in physics. It's extremely hard to understand. I don't really understand it that well, but it does make predictions about those new, like the indirect observation kind of predictions like we see for the electron. And they haven't been tested yet, but they are testable.
But what sort of predictions with regard to the nature of time and change?
That time and space are emergent from a more fundamental property having to do with Hilbert space or quantum stuff that I don't understand.
Yeah, I'm. Anytime anybody talks about real things being emergent from a mathematical construct, I get very, very suspicious.
All
Very
right,
fast.
he's not saying this mathematical construct. He's saying that there is this.
I mean,
This
that's what Hilbert space is, though.
Hilbert space is a description of all the possible vectors of a system, and that's the quantum physics stuff of the Feynman equation. So he's using the same mathematical models that have been able to be used to make successful predictions in the Feynman diagram. So that has been empirically demonstrated. We know that whatever this equation is, it's describing some part of reality, and we're going to call that, or he's going to call that, the amplitude-hedron, and that thing is what time and space emerge from.
Okay, so he actually is careful enough to say it's a real thing that simply has some properties of a Hilbert space.
Yes.
Okay, that's good then, because you had said it a moment ago that it emerged from a Hilbert space.
Right. That's just
So
my lack of clarity. But yeah, he calls it.
okay,
It's an actual thing. It's called the amplitude-hedron. He gives it a name. It's kind of like a particle.
okay, and well, okay. In any event, since you're unfamiliar with the specific with the specifics of what the thing is, it's therefore impossible to discuss it. Um, so I guess the only thing to do at that point is to move on. So since we
Well,
don't,
here's my question: is how is that different from the theological viewpoint? So I have a viewpoint which I align with, which is more the physics viewpoint, which has a solid empirical foundation based on the equations, which can be verified, and the theological viewpoint is grounded in what? How can that be equivalent or better than the physics basis of the interpretation of time?
well, you're talking about one particular theory that is so unspecified it may be entirely compatible with what I was saying.
Right, but I could say the same thing about yours and say maybe your version of a theistic God could be entirely compatible with essentially this new kind of quantum physics thing.
For all I know, it could be, but I mean that. I mean, obviously, from from the theistic perspective, obviously quantum mechanics is compatible with God existing.
Right, I mean, like there could be something superior or something uh, trans the God existing. So there could be something above or beyond the existence of this God thing you believe in, more fundamental to reality, and that your God is a result of this more fundamental thing.
No, that you can't do.
How so?
Um, well, it's due to the nature. I mean, it's due to the nature of God of being uncontingent.
Well, couldn't I
I
just
mean,
say
this goes to the argument from contingency and necessity, but a non-contingent thing cannot be contingent on something.
right? So what I could attribute the same kind of a non-contingency to any natural phenomenon, like for example the amplituhedron, and I just say, well, the amplituhedron is non-contingent, therefore it can't be created by something else, therefore it is also incompatible with the God hypothesis.
That could just be your name for God, then.
Well, no, I would say because it has no consciousness. I would say deliberately.
Well, how do you know that?
The same way I would say that you think it is conscious. I would just labeling it as such. So
well,
I would say
no.
that.
I mean, there are arguments for why God is conscious, but I mean, like, by analogy.
Right.
But,
So my argument is that those don't work, and I can use similar arguments from analogy for it not being conscious.
how would you do that?
Well, for example, everything we know that exists so far is non-conscious, with the exception of minds and physical, as far as we know. And so it makes sense that whatever the fundamental necessary thing is, it would also be non-conscious, like everything else for the most part.
Well, how do you know that everything else is non-conscious?
As far as we know, everything else is non-conscious. It's an argument from an analogy.
Well, no, that's an argument from ignorance, actually. You're saying you do not know that something is conscious, and therefore you're inferring that other things aren't conscious.
All right, sorry, from induction. It's saying that as far as we can tell, none of these things prior to minds are conscious. Therefore, it's reasonable to infer that none of the things prior to them are conscious as well. So if you like white goose, white goose, white goose, white goose, white goose, the next goose to infer is reasonable to assume is also going to be white.
Sure, but a white goose is something that you positively know.
What?
A white goose is something you positively know. You see the goose and see that it is white and say it is a white goose.
Well, you could be deluded and maybe it's not white, maybe it's the figment of your imagination. So you can't be absolutely certain about that.
Well, but okay, but if we'll grant you for the moment that a goose that you see is white, nonetheless, that a goose that you see is not conscious, or
so I would make the analogy and say that when we look at planets and particles and space and time, those seem to be equally as obviously not conscious as the goose appears to be white. Now, is it possible that they're conscious? Absolutely. Just like it's possible we're deluded about the goose, but I can say we can be equally as confident that the goose is white as that electrons are not conscious.
Really? Because I mean, the funny thing about electrons is they actually behave a lot like conscious things in that they sort of follow rules, but only when they want to.
Well, I would say they always follow rules. There's just probabilistic rules. I'm not sure how that would be analogous to consciousness. I don't follow that connection.
I mean, probabilistically, most Americans don't fly to China. I mean, they could if they wanted to. They just don't want to. I mean, probabilistic rules is simply saying that you don't know what's actually going on. It just has observable trends in what actually does happen, but you don't understand the underlying mechanism.
Right, and we can say the same thing about weather and waves and things that are too complicated for us to do the math on at any given time. So I don't see how that makes an analogy to consciousness. Why would you say that electrons are like consciousness in some way? I don't get it.
Well, okay. Name something that you believe to be conscious.
Me? Myself?
Okay. Now, do you tend to do, are there things you tend to do? Like you tend to get up in the morning at a certain time?
Sure.
But sometimes you don't. Sometimes you vary.
Sure.
Sometimes you get up early, sometimes you get up late.
Sure.
But you tend to. You follow probabilistic rules about when you wake up.
Yeah.
Okay. So looking at one conscious thing, you don't follow any absolute rule in this fashion, but your conscious choice tends to follow patterns.
Well, again, I can say the same thing about weather patterns. Again, just like you said earlier, the probabilistic thing is more of a measure of our ignorance, not a measure of it being just some kind of intrinsic thing there. So it could be the case that we're all determined and I wake up at a specific time or in some range of a specific time because of determined reasons we just can't calculate yet, just like we can't calculate the precise nature of the weather. And so we give it a probability. Similarly to the electron, it's just a probability we assess because we can't precisely calculate it yet.
Well, let me ask you this. If an electron was conscious, what would you expect it to do? What would you expect its behavior to look like?
Deliberate?
With regard
Purposeful?
To what? With regard to what purpose, though? Because remember, purpose is with regard to, purposeful is with regard to a purpose.
Right. So if it was conscious, I would assume it would have to like pursue some kind of a purpose or some kind of a goal But as far as I can tell, they don't. They just go in a straight line at the speed of light until they hit something. It doesn't appear that they have some kind of directed process in any way. They're just.
Well, they don't do that though.
What do you
I
mean?
mean, that's the whole nature of quantum tunneling, is that they do things that they're not supposed to do.
What do you mean, quantum tunneling as in the entanglement?
No, quantum tunneling is in like when they do things they don't have the energy to do. When they're in an energy state that they shouldn't be able to engage in a chemical reaction, and they just every once in a while they do anyway. Or
I'm not
or
familiar with that.
yeah, oh yeah, it's a fascinating thing actually. If you chemicals, right? Below a certain temperature of activation energy, you should have zero chemical reactions going on. But that's not what actually happens. You actually do have a very low level of chemical reactions going on, despite the fact that they're below the activation energy for it, because electrons aren't well behaved, actually.
Well,
And
I'm
so,
familiar with quantum tunneling, where the fact that an electron can pass through a seemingly solid object, which it shouldn't be able to because it's diffused into a wave form, and it can go through it and recollapse on the other side of the medium. But
no, that's the electron double slit experiment. Tunneling refers to the energy diagram, actually. The name, it's a metaphor, because if you look at the energy diagram, like the electron would have to have more energy to do this thing, and then it could then like go through the reaction and be on the other side. It was an analogy that instead of actually getting that energy to do the reaction go on, it was like it tunneled through the energy diagram. Tunneling is not a physical process that goes on. The quantum tunneling refers to, by analogy, to the energy diagram. It's as if, like, instead of actually behaving the way it was supposed to according to the normal rules, it just like tunneled through the energy diagram.
right. It's the delayed quantum eraser, where it's the particle can pass through a solid object if it has, and it can collapse on the other side of the medium. I'm pretty familiar with that, but that isn't. It has the energy to do that intrinsically. There's always a probability it's going to do that. It's just a low probability. It's not that it's missing the energy. It already has it. It's just low.
It doesn't have it according to the classical model of it. That's one of the things that quantum introduced on top of the classical model of chemistry, is that electrons can do things that according to the classical model they can't.
Oh, right. But that was because, like you said earlier, our probabilities were just a measure of our ignorance, and then once we could understand them better, we can describe them more accurately. It wasn't the fact that it was doing something it couldn't do. It was just doing something we couldn't understand it could do.
Yes. I mean, I'm sorry. I was speaking a little bit poetically when I said it couldn't do it. What I meant is, according to the understanding of the time, it should not have been able to do this thing. And according to the normal ways in which this happens. What's curious is if you look at that base reaction rate of when you like super chill things down, and this is, it's actually a problem for working chemists, that reactions that should be completely stopped dead when you put things into super deep freeze don't actually stop completely dead. So the funny thing is too, that rate of reaction continues to go on even when you start getting enough energy for the classical equations to work and the normal things to ramp up. You always get slightly more reactions than you should.
Or the Bose-Einstein condensate, right?
No, that's something different, and one I am not sufficiently familiar with to talk about. The Bose-Einstein condensate is something rather different. I thought that had to do with when you chill things down to like basically completely absolute zero.
Right, but there's still that probabilistic virtual particle activity is still going on there, which causes certain kinds of interactions with strange things, like the water can go uphill.
I'm not familiar with that, but I mean, no one's actually hit absolute zero, so no one's been able to empirically verify what happens at absolute zero.
Oh, yeah, you don't actually need to get it to absolute zero, you just need to get it close.
I thought the Bose-Einstein condensate, I thought no one got close enough for a Bose-Einstein condensate.
I'm pretty sure they have. I think we've actually demonstrated it.
Has that actually happened?
I think we have video of it.
Interesting. I have to look that one up. That one's interesting. Anyway, so the thing about electrons, sort of to get back to it, that they would move. You would expect electrons to act according to some purpose. The problem is you don't know what their purpose is, so you can't really evaluate whether or not they're acting with regard to it. We do know that they don't, in fact, simply move around like they're 3D billiards. We've observed that they don't do that. They don't follow simple, Newtonian mechanics laws. So whatever they do, it is not something where they just, you can't predict ahead of time exactly what an electron is going to do. For a single electron, you can't say ahead of time what this one's going to do with certainty.
Right, but you can definitely say it's going to go in a particular direction with certainty. It doesn't go backwards. It never reverses suddenly. Like if you expected every electron was conscious, they would essentially be like just going off in random directions, changing direction, going in every possible way, but that isn't what happens. It's more like rocks or the little marble game where you drop marbles in and they hit the little pins and they fall the way down, and you get like a probability distribution. It's in fact it's the exact same as that, where if you would just have a whole bunch of marbles in a row and you drop them all from the top, you get the exact same kind of probability distribution. So it seems equally as reasonable to believe that the electron is conscious as it is that the marbles are conscious when you drop them.
Well, actually, I mean, the marbles you can, to at least a fair degree of accuracy, you can actually draw out the mechanics and predict where they're going to show, where every individual marble is going to show up. But I mean, the thing is, the same thing is true if you look at people. I mean, if you plot out, like look at people and plot out, like, what professions do they go into? You find them following statistical distributions. Like, it's really hard to predict what any given one person is going to go do, but statistically, you can predict on average what people are going to go do.
Right. So I would say that people are also determined. I don't think that consciousness, there's like a free will aspect to it. So from my perspective, I don't see any reason to think that from consciousness, as I would define it, would be a deliberate way to change an action based off of something, some kind of intentionality. Whereas as far as we can tell, electrons don't do that. They don't have this intentionality. They're just falling rocks, essentially. I don't see anything in what the electrons do that can be correlated to a decision or a purpose. Whereas humans, we can articulate those things. So could they have one? Absolutely. We could be in like a idealistic universe where just everything is fundamentally mental. But I don't see any reason to jump to that conclusion because everything follows the same probability laws, whether conscious or not.
Okay, so basically you have so essentially you have a bias in favor of determinism.
Well, it seems to me
that is to say, when you look at something, you can't tell one way or another whether or not it is a deterministic system. You prefer to assume it is deterministic.
well, deterministic or random, either one of those would be a possibility. But when I look at the things that I can clearly classify as conscious and non-conscious, like rocks and people, the probability distributions apply to both. So I can't use probability distributions as indicative of consciousness or non-consciousness because it applies to both.
Well,
And
but again, you're assuming that the rock isn't conscious.
well, as far as I can tell, when I look at things based off of the knowledge that I have to be able to distinguish between conscious and non-conscious things, with my current level of knowledge, which I could be wrong about, it seems to be clearly the case that people are conscious and rocks are not conscious. Just like it appears to me that the goose is white and I'm not under some delusion that it's purple or something. And so I would say with equal confidence that the goose is white as that the rock is not conscious. Could I be wrong? Absolutely. But it seems clearly the case with as much certainty as we can have that the rock is not conscious.
Well, I mean, that's curious though, because that's not normally when you try to prove a negative, you go, to prove a negative, one works by contradiction in ordinary terms. Like, I can prove there's no whale in my office because if there was, it would be squishing me against the wall. I'm not squished against the wall, therefore there's no whale in this office. Like a big one. I'm not talking like a tiny little baby. You can work it out. Like, if it's supposed to be like a tiny little micro whale, then at least above a certain size, I would hear it's flopping on the ground or what have you. I don't, and therefore it's not there. That is to say, it's you prove a negative by contradiction ordinarily, but you don't have a contradiction to the rock being conscious.
Right. I'm not making an
argument. Not motive, but I mean, for all you know, the rock is a philosopher who just sits there contemplating mathematics. Now,
just a stoic. That's what the Stoics become. They become rocks.
Now, obviously not, using a, neural network in the same way that we have, because we can crack a rock open and look at it and see that clearly the thing doesn't have, a network of neurons inside of it. So obviously not in the same way as us. But you don't have, so far as I can see, any sort of contradiction to the rock being conscious. All you have is the absence of seeing how it would be conscious. Now, obviously, it would have some sort of non-motile consciousness because it doesn't, move around, because it doesn't have muscles and so
right. So I'm not making an argument that it can't be conscious. I grant that idealism is a possibility. My argument is an inductive argument that based off of what we can define as conscious, it doesn't fit the definition of what is demonstrably conscious. Whereas people, animals, I would grant, certain insects, anything that can deliberately act seems to fit that definition inductively, whereas rocks inductively do not.
Okay. So, I mean, you do well. Okay, electrons do, however, move around. So if we move off of rocks, well, in a very very technical sense, they are moving because of all the vibrations and whatnot. Um, and we simply don't even have the accuracy with which to measure whether or not they vibrate in some sort of fixed pattern versus a pattern that shifts around in ways that could be consistent with some sort of uh, with some sort of purpose, given that the vibrations of the rock are so extremely small. Um, but with regard to electrons, their motions are quite large with regard to to their own, call it a diameter. I mean, we don't know what they actually look like, um, and the but at least you use the diameter of the electron in the sort of standard, somewhat analogical sense that it's used in. Electrons move around with regard to quite a bit with regard to the size of their own diameter, at least as much as a dog or person moves around with regard to their own size.
A lot more actually, but yeah, but I don't see how that relates in any way because so do asteroids and specks of dust that are flying through space and stars and all kinds of things. They move around
Well,
significant amounts compared to their size. But I
right.
don't
I'm just saying that the disqualification of the rock that it doesn't move does not apply to the electron. That's all I'm saying.
Oh, right, right. My argument was not that it wasn't doesn't move; it is that it doesn't have any of the inductive properties that we attribute to consciousness. It can't, as far as we can tell, react. It can't make a decision. It can't make a purposeful, meaningful interaction. It can't evaluate outcomes. We don't have any way to assess that a rock can have any of the properties that we would attribute to consciousness.
You mean an electron, right? Because
Either
you
a
just said a
rock,
rock.
right, right. So either one. So, like when we evaluate, does object X have consciousness or not? We ask questions like, well, does it react? Does it
Well,
interact?
electrons clearly react and interact with things.
Right, like without any kind of physical interaction. Like if I showed it a picture, would it go one direction as opposed to the other? And the answer is no. As far as we can tell, it doesn't have preferences.
Well,
It's
I
purely
mean, you have to hold up there because you have to say what sort of picture, and I mean, you would have to adjust for the sort of interactions the thing is capable of. In the same way that if you show a blind man a picture, he's not going to react.
right, exactly. So there has to be some way that it can react. You have to have some interaction with it, which would cause it to react in such a way that it would be able to make a deliberate decision. And we have no way of doing that. Every interaction that the particles, that electrons seem to have, seem to be purely either random or determined in some sense. There isn't like a choice aspect there as far as we can tell, as opposed to like if I give a dog a tennis ball, it's going to react in a particular way specifically to the tennis ball.
Well, right,
Whereas,
but hold up a second there. An electron, of course, being rather noticeably smaller than a dog, um, its purposes and so on would likewise be rather significantly smaller than a dog. So, in order to say that it can't act with purpose or that we can't see it act with purpose, you'd have to first establish what sort of purposes could it be acting with regard to. I mean, the first thing is essentially, they'd move around something along the lines of by feel, right? The electric field is their primary means of interacting with things, which is at least analogous to moving around by feel. You
okay,
push against things and you feel things pushing against you and you feel things tugging on you. Were you an electron? You in some sense feel those things. It's a very analogical sense. So the interactions would be something along those lines. There'd be how you push upon things, there'd be how you pull upon things, and there'd be where you move to. Those are the basic things that an electron could do. So to say, is this thing conscious? We'd have to, ask like, okay, what could its purposes be? Now, there's nothing analogous to writing a book or reading a poem or watching a movie for an electron, in that those are highly composite activities. For us, an electron is so small, it doesn't have those sorts of composites around. Everything it interacts with is, composites of a few things at most, right?
yeah,
Three quarks bound together into, into a proton, ditto for a neutron, just another electron, and a whole host of other particles and tons of photons of various kinds. So these things are all very, very small. So it wouldn't make sense to ask whether or not could this thing read a play, because you can't, so far as we know, at least there's no way we could interpret a play being on a proton. Again, with the same caveat you said, that for all we know, there is some sort of play that an electron is capable of beholding in some sort of, incredibly subatomic way. But, we have no way of knowing this and no way of measuring any such thing in any fashion, whatever. But we do have the ability to try to find out where it is and where it goes, and whether it goes in completely deterministic ways or whether it goes in unpredictable ways. And we do have, and within that, it doesn't go in the deterministic ways. So, if it moved in completely deterministic ways, single electrons, then, clearly we'd say, like, it really looks like it's not conscious because it just moves in this incredibly deterministic fashion. It doesn't do that. So we can't say it looks deterministic in that way. We're then left with a problem of what sort of purposes could this thing have, assuming that we're not just anthropomorphizing it and assuming that it's got to be interested in poetry and movies and so on. But it would have, presumably, electron-like purposes, which would have something to do with its interactions with other subatomic particles. Also, with how it moves around is its sort of primary way of interacting with these other things. And then it seems to me we're left in much more of just a simple state of ignorance, because we can't really enumerate. There clearly could be some sort of purpose at this level. It would have to be something at this level. It would have to be, something to do with its interactions, through these fields and with other particles. But we can't say what that purpose could be, so we cannot say whether or not its actions are consistent or not consistent with that purpose.
Right, we could always come up with a purpose and say it is consistent with the purpose, but wouldn't the one claiming it has a purpose have the burden of proof to demonstrate there is such a thing?
Well, the burden of proof is only relevant to somebody trying to prove something to somebody else. It's not relevant to somebody asking what is out there.
Right, and so from my perspective, it seems as if the case that if we make an analogy to the things we can show are conscious and the things we can't show are conscious, an electron is more analogous to the things we show are not conscious as far as we can tell, and they have less in common significantly with the things that are conscious. I mean, like if we compared a person, an electron, and a rock, the things that have the most in common would be the electron and the rock, not the electron and the person.
Oh, some people?
Yeah,
I'm half joking there. Some people, you wonder about a little bit. But joking aside, obviously the electron is... the electron actually doesn't seem to have more in common with the rock than with people to me. I mean, rocks just sort of sit there. Electrons do all sorts of weird stuff. I mean, between them, people do weird things. Rocks don't do very weird things at all, and electrons do incredibly weird things. I mean, of the three of us, human, rock, and electron, the electron is by far the strangest.
well, I would say that rocks do incredibly strange things, like rocks form planets and asteroids and lava and magma and all kinds of things, crystals and diamonds, rubies, all kinds of things. So rocks do a lot of amazing things.
Lava's not really a rock, and it's not rocks that form crystals. Well, okay, there are certain cases you can get the stuff to move as long as you use a liquid substrate and so on to catalyze that reaction.
A rock is just a compound mineral. So
right, but I mean, sitting there on its own, it doesn't crystallize. You need some sort of intermediation of other things that cause it to move around.
right, exactly. And I would say that the same is true of the electron, that it has to do with the probability space is like the other thing that's causing the rock to move around. It's the interactions of gravity or something. And the fact that we can't measure that, or we can actually measure that, but we can't demonstrate that as a physical thing, doesn't mean the electron is conscious. I still see, if we asked most physicists, is an electron more like a person or more like a rock? Most physicists are going to say it's more like a rock.
I mean, I don't see how that's anything but a cultural bias. I mean, most physicists aren't philosophers, and physicists specialize in dealing with equations. They don't specialize in thinking about the nature of things outside of equations. You can actually find a decent number of physicists who will tell you that physics means literally nothing but the equations. That anybody who says anything past the equations is simply straying outside of physics.
Right. That I would agree with that. But even if I ask philosophers, we're going to get the same answer.
Well, it depends on. It's going to depend on how exactly you ask the question. Because if you bring, I mean, the thing is, if you talk to most philosophers and you actually phrase the question properly, such that you are indicating, are you talk, do you actually know that the thing is not conscious? You're not going to get nearly so clear cut an answer because electrons from observation do lots of things that rocks don't.
Well, actually, I'm pretty sure because most philosophers are fallibilists, they would probably say, "Yeah, we can know that the electron is not conscious." Because the whole premise of fallibilism is that we can have knowledge even if it's not absolutely certain. So we use the same inductive or abductive basis to say that just like we can conclude that rocks aren't conscious, we can conclude electrons aren't conscious for the same exact reasons, as they don't have the properties that we would attribute to conscious things, like people and dogs and cats and not politicians.
The it would be interesting to run that survey because I believe you get very different results than you're predicting, especially if you. Well, there's going to be some dependence too on how exactly you define philosophers too.
Well, there's
So,
actually a really good survey that's asked the same general questions called the Phil Surveys paper. It's the most detailed survey of philosophers I think ever, or to date at least, and it has some interesting perspectives on what philosophers mostly believe, and that's one of the things where I get the fallibilism. Most philosophers are fallibilists from.
well, I mean, one of the problems though is that you're going to have to include. I mean, almost certainly because I think I've seen that they don't include theologians, but theologians all actually are philosophers. They're just you already know a bunch of things that they positions that they hold in it, but they all certainly do philosophy. They all have philosophical training and they all do it. Um, the I think we're kind of pushing the end of where this is a productive avenue of the discussion. Um,
Well,
so
can you summarize your point a little bit? So, my main question is we can both interpret what time is, we can both interpret what consciousness is in different ways, and it seems to me to be more supported on the physics naturalist side, and you're saying that the theist side is more supported. How so?
well, I mean, for one thing, it doesn't rest primarily on an argument from ignorance. Whereas the side that you're calling the physics side, which is rough, more properly called something like the physics exclusive side. That is to say, physics minus anything else. Rather, because I mean, obviously, the theistic side also includes physics. The theistic side, fully affirms that physical reality exists and behaves according to some nature and so on. So, and to the degree that physics correctly describes that nature, physics is therefore correct in the theistic side. So, I mean, both sides affirm, whatever is true in physics. The So it's sort of the physics exclusive versus the theistic plus physics would
You said
be a more accurate description of the two.
you said that the physics is rests on an argument from ignorance, whereas the theology doesn't. Can you explain that more?
The physics exclusive side rests on the argument from ignorance. That is to say, it says we don't know whether or not this thing is conscious. We do not, we do not know what purposes it could have and cannot therefore evaluate it according to what purposes it could have, and do not therefore know whether or not the thing is conscious, which is an argument from ignorance. That is to say, its starting premise is we do not know, and then it concludes something based upon that lack of knowledge. And it's not an argument from contradiction. It's not that we would know if it was, but we don't, therefore it is not. It is rather simply starting from we don't know, can't describe it, can't evaluate it, therefore we're concluding that it isn't.
Well,
Or provisionally acting as if, I mean, whatever variant of conclusion you want, such as that's saying we're going to base our actions in the world upon this premise.
so
Or, upon this
I would phrase it by saying we have no reason to believe that there is consciousness outside of physical brains, and so you would hold the burden of proof to demonstrate otherwise. And so I wouldn't say that's an argument from ignorance. I would say it's a burden of proof fallacy, that you're trying to shift the burden of proof onto the physics exclusive side to try and disprove or to prove a contradiction that there is consciousness there, whereas the physics side is just saying we have no reason to believe that at this time. Because, or for example, we could say the fundamental nature of reality is like the magical spaghetti from the spaghetti monster or something. We don't know that it's not the case, therefore we can't exclude it. But since we have no reason to believe it's the case, we can say it's not a reasonable conclusion that the fundamental nature of reality is magical, non-physical spaghetti from the spaghetti monster. So I would put those as kind of the same thing. As you want to argue that the electron could be conscious. Yes, it could. We can't disprove that. But it could also be magical, non-physical spaghetti. We can't disprove that either. But since we have no reason to believe either is the case, we can both rule those out until evidence is provided one way or the other.
Let me see what was a good name for that. See, I mean, the problem with that is that the burden of proof is completely and utterly irrelevant to a person who's doing investigation. See, the thing is, when you're doing investigation, the whole point is to say what is out there. No one's supposed to prove something to you. You're supposed to go find it. That's the whole point of physics, is to go find what's there.
Right.
Physics rests entirely upon rejecting the concept of the burden of proof and going and finding out what's actually there. A physicist doesn't sit back and say someone else's job is to prove something to me. A physicist said, my job is to find out what's there. Now, what you're doing, however, in saying, invoking the burden of proof, is that you're saying, no, I'm not going to go investigate. I'm going to use a conclusion without knowing that this conclusion is true, because no one has gone and proven this conclusion to me.
I would rephrase that a little bit. So I would say that we can demonstrate the conclusion to a point. We can't demonstrate it beyond that point, and so we're going to inductively infer it's true beyond that. Like, for example, every time I pick up this cup, it doesn't fall through the floor when I put it down. I mean, that's inductively the case. I can't prove it to be the case because we can't, like you said earlier, we can't prove something infinitely is going to be true in all cases. So it could be the case that, like, in the next second, I'm going to put it down, it's just going to fall through the floor. But inductively, that isn't a reasonable conclusion because we have no reason to believe that is the case. Whereas we do have reason to believe that when I put it down, it's going to stop and hit the little cup holder thing I have there. And so I would say the same thing is true in the case of consciousness, whereas we have a strong inductive reason, just like we have a strong inductive reason that the goose is white, that particles aren't conscious. We don't have any good reason to believe they are conscious yet, just like we don't have any good reason to believe that this cup is going to fall through the table and hit the floor.
Well, I mean, you do, in that they don't follow any deterministic rule. On an individual basis, they don't follow a deterministic rule, which is one of the primary signs of consciousness we use throughout the world.
I would not accept that at all. I would not say that that's property that we attribute to consciousness.
I mean, if you the basic test that people apply to see whether or not something is conscious is not whether or not it serves some purpose. Because, I mean, lots of machines that we make serve purposes and we don't attribute consciousness to them.
Right.
I mean, my mouse serves a purpose. It acts according to a purpose. We don't attribute consciousness to the mouse. Because the mouse...
It would be some kind of like a deliberate purpose or an intentional purpose as given from the individual, the thing itself.
Well, the thing is, if it were to follow this purpose without any sort of deviation, if we were to follow it in a completely mechanistic way, we would attribute it being a machine. The thing we look for whenever we look for consciousness is whether or not the thing moves outside of the normal rules in which, mechanistic things actually move. A body floating on the river downstream, we tend to assume is either dead or asleep. It's it could also be just a person lying. That's one of those things where you go and check to see, because that's the sign of a corpse. Whereas the person swimming upstream, doing the thing which is not deterministically given by the rules, is where we look for some sort of consciousness. Well, now, whenever you see a machine, whenever it repeats, we tend to assume not conscious.
Well, I would say that you need to look for some kind of deliberation. There needs to be a choice, a purpose that can change based off of some internal action of the thing. So there has to be
and the external sign of this is non-determinism. That's to say, the inability to predict it on a one-off basis.
Well, no, I reject that, because we can say the same thing about weather. Weather has a non-deterministic aspect to it. We can't calculate that. Same with waves. Same with certain kinds.
Yeah, but I mean, human beings almost invariably say that. Human beings almost invariably have attributed purpose to weather, precisely because weather has that sort of property. There are people who have a particular belief that utterly excludes purpose being in any physical thing who therefore do not attribute it to weather, but almost invariably human beings do. I mean, they pray to rain gods, they pray to God over the weather. They attribute purpose to the weather precisely because the weather is not deterministic in that fashion.
Well,
You can't
people have
predict it.
worshipped everything. There are 30,000 or 3 million gods in Hinduism, one for just every possible thing that could ever happen. But it seems to me that most philosophers, most physicists, most scientists would pretty much agree with a high level of confidence that rocks are not conscious, electrons are probably not conscious, people are conscious, dogs are conscious. It seems to be the majority would agree with that pretty consistently. It doesn't seem to be a high level of contention there. Like, I don't think that many people, many experts in any of those fields would grant that simply because it's non-deterministic that that's indicative of consciousness in any way. And I've never heard that argument before. I don't know.
Well, I mean, talk to anybody and ask what is the external sign of consciousness. What do you look for as the first thing to tell whether or not something is conscious? And because you can't tell looking from the outside about an internal process. I mean, yes, you're defining things in terms of an internal process, and fair enough. But the problem is we don't have access to other people's internal processes. I have no idea what's actually going inside your head, going on inside your head. You have no idea what's actually going on inside of mine. Hence, the Chinese room problem. Hence, the mechanical Turk, and so on. Like, we infer consciousness from outward signs because we can't actually directly experience that internal process in someone else.
Right, but those external signs are usually some kind of interaction between consciousnesses. It's not just a reaction, it's usually an interaction. So it's some kind of ability to change purposes intentionally in some way uh, based off of some input, which is not just a reaction. Whereas the electrons clearly seem to be reacting specifically due to the collapse of the probability wave. I mean,
What's your definition of a reaction that isn't an interaction?
a more deterministic process where it's just reacting to an interaction as opposed to making a decision. Like if I asked you, what is think of an elephant or think of an animal. I mean, you have to make a decision there. You have to choose between a variety of possibilities, and it's not just a reaction because you're not. I'm not just saying pick an elephant or think of an elephant. So you have to choose. Whereas there's no choice for the electron; it's just acting. It's not like the electron isn't deliberating about it as far as we can tell. There's no possible options there that would like, I'm going to go with this one over this one. Like, no, it's just it's just falling into place, just like the rocks and just like the marbles in the little chain.
I mean, they do things that are directly analogous to choice all the time, though.
Like
In
what?
terms of like which detect, you fire an electron at the wall, where does it actually hit? Seems to make a decision. I mean, you sure as heck don't know ahead of time where it's going to land on the wall.
Well, that has
The famous electron double slit experiment, where you fire them off one at a time. You cannot ahead of time predict. I mean, in what way is this different than observing the thing, making a choice, and showing up somewhere?
because it follows the exact same pattern as dropping the metal balls that hit the little plastic pins. That it goes the exact same probability pattern with 100%. It's not a choice.
No,
You get people, they're not going to get that same kind of probability distribution. You're going to much more random distribution.
no, you do. I mean, just large numbers of people, like really large numbers of people, follow probability distributions constantly. But
Only in regards to specific things that have like.
we only have a few tests we can run on electrons. I mean, there's a very limited number of interactions that we've managed to do and observe with electrons. It's not tens of thousands of different sorts of interactions that we've had with them. I mean, the number of experiments you can run is fairly small, and well within the number of things you can easily find that human beings, when they, you have a bunch of entrances and so on, they'll follow a statistical pattern, how they go into them, exits, how they go out of them, how they line up at bathrooms, what classes they take in colleges. I mean, these things all follow statistical distributions. I mean, there are entire industries called, insurance, based upon people following rather, statistically predictable patterns. And yet, all throughout them, people have choices that will affect these things. People can go and commit suicide in very large numbers, which will mess up the actuarial tables like hell. People can do all sorts of things that will screw up the actuarial tables, but don't. The actual aerial tables work remarkably well. And moreover, there is this statistical reliability, which is observable with human beings, but the electron, when you fire a single one of them, since, the the making a decision, which you talked about, was an individual thing. When you're talking about individual electrons, you fire it, it seems to be making as much as it does anything else, it seems to be making a decision about where it's going to show up, because you have no idea where it's going to pick to land on the wall when you fire single electrons through the double slit experiment.
Right. Well, the problem is that all of the same experiments that we can do on electrons, we can do with the marbles. We get the same results and the same probability distribution. So unless you're going to argue that the marbles are themselves conscious, then it doesn't make any sense to also say that the electrons are conscious.
No one's ever run a marble double slit experiment.
Yeah, they have. That's the same thing. You do it with the waves. You can mimic the double slit experiment if you're using water and waves. You get the same results.
Now, you can't do a double slit experiment with a marble. The wavelength of the marble is so insanely small, you couldn't actually devise the experiment.
Oh, no, you do it with water. You just use the water to mimic the probability wave, and then you put the marble floating on the water, and it'll flow through the holes and distribute in the exact same pattern. So you can do the same experiment with the marble on water, if it's floating on water, to get the same results. You can get the same experiments with the same results purely through marbles and water. There's not like an experiment you can do with an electron that shows it does some kind of absolutely miraculous thing that can't be replicated in other systems. It's just it has the same properties as all other physical systems. Whereas humans do all kinds of these other kinds of experiments that get random results that we have no idea about. It seems very obvious that humans have consciousness because we can get these spectacularly odd results.
That doesn't seem to be correct at all with the marble, though, because you don't have a quantum phenomenon going on with a marble floating on top of water.
Oh, right. I'm just saying that the same distribution, the same results, the same outcome can be described with a purely non-conscious system. So
the same statistical distribution can, yes. And the same is entirely true of human beings. Everybody line up here. You can easily line up, marbles in a line, just like you can line up people in a line. And statistically, the people who got told to go up in a line will get in a line, just like if you put a bunch of marbles in a line. I mean, the mere fact that you can replicate a statistical distribution under a particular circumstance doesn't mean anything about the individual things going on.
All right, but it's the people say no. The marbles can't say no, and the electrons can't say no.
We don't know that the electrons can't say no.
Well, as far as we can tell, we have no experiment that they can reject or refuse this pattern or go to do something else completely. Like in the double slit experiment, there aren't any. It's always a distribution pattern between particular lines. It's not like they don't start going vertically. There's no vertical pattern there. It's always
that's the distribution pattern. I'm talking about individual occurrences.
Right, but that's my point, is that there aren't any electrons who disagree and say, no, I'm going to go do this my own thing over here. It just doesn't happen. Just like there aren't any marbles that just go off and do their own thing. They all follow the pattern. They don't have the no option, whereas people have the no option. Like, I'm not going to line up. Go away. Stop bothering me.
Actually, I'm fairly sure that's not the case. I mean, when you run those things, when you fire an electron, it doesn't actually land anywhere on the wall. You just call that experimental error. But that's not. It's because, I mean, the thing, amongst other things, the electron has the option of bouncing off the wall and coming back. I mean, even the problem is you'd have in practice.
I'll give you an example. So let's say we do the double slit experiment. Instead of vertical lines, we get horizontal lines. Like if that happened,
that's the distribution,
right?
We're talking about singleton events, not distributions.
Well, you can have distributions that change too. So, for example, you can have a group of people who say, "No, I'm not going to line up," and so they do.
But we're talking about singletons, though.
Right.
So it's got to be a singleton thing. And the problem is, if you fire a single electron, it doesn't hit a detector on the wall. Given the precision involved and so on, you're going to have a hard time telling between that electron said no and I didn't fire that electron precisely enough at the slits so that it ended up bouncing off someplace else at the front wall.
Right, a single electron doing something, we wouldn't be able to tell one way or the other. So we'd have to go with the groups here. If we have a distribution where the grouping is so significantly different than the expected result, and it's not the same diffusion pattern, it's a completely different diffusion pattern, like an ink blot kind of pattern, and we get bunches of random ink blot kinds of patterns, and sometimes they make lines and sometimes they make boxes. If we got all of those things, then it may be reasonable to conclude electrons are conscious, because there's enough of a distribution of random occurrences that have just no correlation to one another that, yeah, maybe there's consciousness there. But since it's always the same pattern we get from doing marbles in water, it doesn't seem reasonable to conclude that it's conscious.
How many times has the electron double slit experiment been run?
I have no idea. We
I'm
should do
willing
it
to,
more,
I'm willing to bet you it's less than 10,000 times.
probably.
It's probably well under
Actually,
1,000 times. It'd be
actually,
surprising if it was as many as 10 times, frankly. The electron double slit experiment's really hard to do because the wavelengths are all so small.
actually, I think it's been done more than that because it's been repeated so many times. But if that did happen, let's say we do a bunch of experiments and we get these completely ridiculous patterns like boxes and triangles and ink blots and things, then that may be a compelling argument that there's something else there, which could be consciousness. But as far as we can tell, everything right now in the probability distribution is just the same as water and marbles. There's nothing about that that says there's something else we need. There's some other property we need to attribute to electrons that can't explain this, which is consciousness. It seems all purely explainable, just like water in marbles is purely explainable without consciousness.
I mean, the same is true of human statistical distributions in large groups.
Well, I would disagree because there's people who can say no. Like you can say, go line up. People say no. I mean, the best explanation of that isn't a physical process. It's that guy has consciousness. He's just
Yeah, but statistically, statistically, human beings in large groups follow statistical patterns.
right, but they can.
Where's where's your example of where you find large groups of people all living in trees instead of houses, or for anything that most people do? Where's your large counterexample of everyone just suddenly bucking the trend?
The Kool-Aid. Don't drink the Kool-Aid. Forget the group who all committed suicide because they wanted to jump on the asteroid that was passing Earth at the time. There are large groups of people who do incredibly strange things that go completely off the rails outside of the distribution pattern.
You're thinking the Branch Davidians? I mean, it's less than 400 people.
Right, and that's sufficient. Like if there was 400 electrons who did some particular thing in a specific direction, that would be pretty strange, and that would get people's attention. That would be good evidence that there's something else about these electrons we need to understand. But as far as we can tell, everything that is done with the electrons is purely just mechanical processes, just like the other mechanical processes we can describe with water and marbles. There isn't anything.
The electron double slit experiments aren't run in that sort of low numerical groups, though.
Right, but if there were, just like, because they send thousands and thousands of them, but if there were 400 of them that went off and all went in one specific direction or some specific pattern away from the distribution pattern, that would get people's attention. If it was just 400 of them, that would still be significant enough to say either there's something wrong with the experiment, we did something, we messed up, one of the mirrors is off or something, or there's some new property of electrons, and consciousness may be that new property. But if it all follows the same pattern with no like spontaneous deviations, and it's just like the water and the waves, there's nothing about that that makes it reasonable for us to extend the properties of electrons to have this new property of consciousness.
It's a really curious argument. I have actually encountered that before, to be fair, that statistics suffices for individual prediction. But I mean, a little bit of a loss for what to answer, except that it doesn't. I mean, the fact that you can't predict individual events is fundamentally different from being able to predict individual events. And I mean, no amount of statistics changes the fact that being able to predict an individual event and not being able to predict an individual event are fundamentally different.
Right, but the individual event isn't what's indicative of consciousness. It's the grouping events that would be. Like my grant that we can't predict a particular electron's outcome, but we can predict the grouping's outcome extremely reliably, whereas in the case of humanity, there are always outliers that completely go off the charts that we can't predict at all, whereas there aren't in the case of electrons. They always follow the same pattern no matter what.
I mean, the thing is, you're heavily mixing two different statistical groupings. I mean, the thing is, like if you run experiments with millions of human beings, which is more analogous to what actually, I don't know, I don't remember the actual numbers. I may not have looked them up. I mean, the problem is you can't actually set up actual detectors for single electrons in the sizes that you would need to in the double slit experiments, that you have to run the experiment in a highly statistical fashion. in order to see the interference pattern, because everything is so incredibly phenomenally tiny, so that you have to run these things with incredibly large numbers. And when you're running things with incredibly large numbers, such that you'd be running like hundreds of millions of human beings, the small variations that you see are statistically insignificant in human beings. I mean, we follow within essentially measurement error, very, very, very statistically reliable patterns.
Well, I would disagree there because there's usually big transitions between human cultures, whereas there aren't these big transitions in the probability distributions of electrons. For example, from one religion to another religion, like when one religion, Islam was at one point the most popular religion in the world, and then Christianity, and then Hinduism was before that. And so there are these massive changes in the distribution patterns in humans where there are essentially no changes in the distribution patterns of electrons. They're always the same. It's always
No, well, the thing is, you're picking things where you're finding changes. You're not setting up an experiment where you have people do things like walk walk through one of these two doors and then pick one of those doors over there to go through.
Well, that's
if you set up an experiment like that, which is actually analogous to what the experiment is, you're not going to see this, and then you run millions of people through this thing and count where they, show up in various doors and so on. They're going to show up in these doors in incredibly reliable patterns.
Right. Well, that's the point, is that there isn't one of those experiments for electrons. We can't get that changing distribution patterns with electrons. We can get it with humans. We can't get it with electrons. We can't get it with marbles, but we can get it with the conscious things. So if you wanted to argue that electrons are conscious, you would need to come up with this other kind of experiment, which can get this really random changing distribution pattern. You'd have to give the electrons a choice, essentially, and let them create a conscious decision image.
Okay, but that doesn't solve the problem of being in a position of not knowing one way or the other.
All right, I can't know that you're conscious. Maybe we're all brains in a vat, or a solipsistic universe, and my brain is the only thing that exists. I can't know with certainty that you're conscious, but we can get evidence one way or the other.
Well, I mean, the only evidence you have so far proposed is that in the few experiments you know how to run with electrons, they're not the sort of thing wherein you're going to see a meaningfully different. Since they're analogous to this, they're analogous to the sorts of experiments in which, if you ran them with humans, you'd get incredibly deterministic statistical patterns emerging out of them. And so you're in the position of not knowing one way or another. And the thing is, you are in the position, I assume, of wanting to know what the world is like. So you don't know, and you don't have a way of knowing. And so to reason from a particular conclusion when you don't know and you have no way of knowing, and moreover, you're not in the position of you should know if it happened, you're in the position of you have no way of even knowing. Now, it seems to me to be what you're doing is you're deciding, I'm going to come to a conclusion because it is convenient to me to come to this conclusion. Not because you think that conclusion is true or have a reason to think that the conclusion is true, but because the conclusion is convenient to you. You're going to assume that they don't have consciousness because it's convenient to assume that they don't have consciousness. And you're going to let somebody else worry about it, which is why you bring up the burden of proof.
Well, it's more like I assume electrons don't have feathers because I don't have any reason to believe they have feathers. Or I assume electrons don't.
I mean, that's bad science, if nothing else. I mean, depending on how, if you're going to define feather as like, what a bird has, then obviously it's not going to, because those are composed of electrons. So it's intrinsically impossible for them to have feathers. But if you're going to say they don't have some sort of subatomic feather, it's a rather, bad sort of science to assume that things don't exist. I mean, that's the whole reason why there exist control groups when we do go into a different science, not physics, but I mean, even in physics, while you do your best to control variables, and in large population research, why you have control groups is precisely because you assume there are probably things you don't know about going on. And so you're going to do your best to account for these things you don't know about, because you almost guaranteedly don't know about them, but they probably exist and probably matter. So you're going to try to do your best to insulate yourself from these things that you have no reason to believe are there. And experience has shown, since we live in ignorance, probably exist and probably matter. So, if you think about it, like when you run, when you're trying to figure out whether or not a drug works, right? You establish control groups because there are probably effects going on that you don't know about and don't know about how they work. And so you're trying to insulate yourself from this. Or, I mean, again, all sorts of control things. Whether you're, you know, you, uh, you're familiar with, if you read Surely You're Joking, Mr. Feynman?
Yes.
Do you remember the story of the, when he was so disgusted with how psychologists run their experiments? Story
Yes.
of the rat. The whole point there was that he was disgusted with the psychiatrist because the psychiatrist assumed that if he didn't know about any outside variables, they weren't there and had no effect. And he was disgusted with him precisely because you should assume that there are outside variables that have an effect that you don't know about until you have gone and proved to the best of your ability that they aren't. So doing your best in particular to think of all the possible outside variables that could exist and then trying to eliminate them. And hence why they went through the getting putting covers over the fluorescent light so the rat couldn't see the light, and putting the maze on sand and so on. They kept actively trying to think of what are the things that we don't know about that could be affecting this, and let's see if we can figure out some way of then trying to insulate this thing from those things. But the whole nature of the scientific method is to assume that what you don't know is significant.
So let me give you a different example. Do you think it would be reasonable to believe we do not exist in the Matrix, that what we experience is reality itself?
Oh yeah, quite. I mean, because this is contradictory to various other things, I think it's reasonable to believe that you don't. But yes.
What do you mean contradictory to other things?
Oh, I'm just going to go Descartes' basic route, and that God wouldn't let us be so completely deceived in this fashion.
Okay, so from the perspective of a materialist who says, I believe we are not in the Matrix and there is no God, do you think that would be a reasonable position for them to have?
No.
Why not?
There's absolutely no way of eliminating such a thing.
All right, so in philosophy, the consensus, in philosophy and science, the consensus is fallibilism. I would really love for you to take a look at like the Stanford Encyclopedia of Philosophy on it, or do some research, and I'd like to hear your thoughts on it, because the consensus right now is that we can be certain, even as a materialist, we can know that we are not in the Matrix. And the justification for that is the position of fallibilism, that if some belief has justification, and if that belief happens to be true, then it can be called knowledge, even if we can't be certain it's knowledge. So even if we don't have infallible knowledge of it, it can still be knowledge. And so I'd love to hear your thoughts on that position in philosophy, because it's really interesting, and I think that's the fundamental difference we have in our positions, is that from my position, we can know things like that an electron isn't conscious and that we're not in the matrix and that electrons don't have feathers, because of the fallibilistic knowledge that we are allowed through the justifications of philosophy. And I would very much like to hear your thoughts on that if you have time to look into it sometime.
Okay. I mean, the really short answer, by the way, is that modern philosophers cheat horribly. I mean, it's a necessary outcome of the route that modern philosophy has gone, and what your academic philosophers are pretty much all modern philosophy. That's modern with capital M. Are you familiar with modern philosophy with the capital M?
No, I have no idea what that means.
Oh, it's a particular school of philosophy. Basically, it started with Descartes. Some argue intentionally, some argue accidentally. Are you familiar with what makes Descartes not his most famous phrase, but why Descartes is famous?
The cogito ergo sum?
That's his most famous phrase. He wrote two books. Can't remember, and then Meditations on First Philosophy, which was the second one that wasn't so much of a sketch. And this is where he entered. He was the first to really in the West. He was the first to really entertain radical skepticism. That is, what if everything I know is false? And Meditation on First Philosophy is trying to answer that question: what if everything I know is false? And roughly speaking, what he does is he basically more or less answers that he proves that God exists, and then shows how God wouldn't let us be completely deceived, and therefore it is reasonable to trust things. He is not basically his actual conclusion, and a lot of people think intentionally and some people think unintentionally, more or less had no effect subsequently on philosophy. But this question of what if everything we know is wrong became sort of the central question of philosophy for a long time. And this is what's called modern philosophy with an M. The philosophy, once it started becoming focused on that question. And then it goes through a bunch. Roughly speaking, the three main stages are Descartes, who poses the question, Kant, who tries to give an answer, where he substitutes, he essentially substitutes projected mental models for knowledge, saying that, okay, yeah, we can't actually know things, but on the other hand, we can come up with mental models, which we then attempt to verify through experience. Then the next basic step there, I'm eliding a bunch of steps in between, is Nietzsche, who points out, yeah, no, that doesn't actually work. And then you have, that's when you get to, basically Nietzsche is the death of modernism, and the birth of postmodernism, where postmodernism is the sort of fully post-truth world, where philosophy accepts that you can't actually know things for real. You can come up with whatever substitute you want for knowledge and act on that, because obviously you have to act on the basis of something. And then, roughly speaking, what Nietzsche points out is that everything is poetry, from the Greek poesis, to make, that everything, what we call knowledge, is something that we are imputing and constructing, and that we don't have. And roughly speaking, after that, modern philosophy more or less follows in it's sort of the postmodernism, which is actually, again, a name, capital P, capital M. Postmodernism is better known in art and in literature, where it basically is just sort of kind of absurd, somewhat on purpose. In the postmodern, you get into things like Sartre with life is absurd, and hell is other people, and so on. But roughly what then happens in philosophy is more or less the view that it's the sort of basic problem is that Nietzsche's right, but the thing is, if you take Nietzsche seriously, you end where Nietzsche ended, which is basically insane. Because you can't live in a pure will to power world. You can't live on the basis of everything you're doing is a pure imputation of your will upon the world, although technically Nietzsche was a determinist, and really it's just the will to power was the thing that was manifesting itself in human beings and so on. But determinism isn't really sayable in human language, so it's always approximated and analogized. More or less, most modern philosophers, plus or minus, will sort of say that Nietzsche's right, but you can't live that way, so you have to come up with something else, so that you have to then come up with something that you can live with, even though it's not really valid. And so I will look into it in specifics. I'm not trying to comment in particular on the thing that I haven't seen, but it sounds like the fallibilism that you're talking about is one of those. That is to say, it is the compromise you make with the fact that Nietzsche is right but unlivable. And so you've got to come up with something that you're going to treat as truth in order to remain sane so long as you're still alive. The basic problem with it, as with all things that go on the basis of assumptions, is that they work until they don't, if you're familiar with that phrase.
Yeah.
And so it's the like we know enough to assume that you don't apply this to holes that you find in the ground. Like, you don't assume that a hole that you find in the ground is empty unless you've got some proof that the hole in the ground is full. Even if most holes in the ground are empty, you're not going to stick your hand into it, because there's a non-trivial chance that something with sharp teeth is actually going to be in there and going to attack you, even though most of the time there won't be. And that's a fairly good representation of what that general approach of epistemology. Again, I can't speak to fallibilism specifically. You can look up the specifics on that and get back to you on it. The general approach always suffers from that you will tend to, just by simple evolutionary process, we tend to avoid mistakes that just go wrong the very first time you make them, every time you make them. And so we for those, we tend to avoid those. And for the things that don't tend to go wrong very often, um, you can do kind of whatever with them. And most of the time, you'll be okay. The difference between being correct and being lucky is in things that don't happen very often, indistinguishable. So just in broad terms, and without commenting on the specific thing, um, that is the general answer that I would give, that it's more or less an attempt to, if you can't be right, be lucky. And then just concentrate on where you can be lucky and hope that that works. And it will for as long as it does.
Yeah, it'll be interesting to hear your thoughts after you research up on it. But there was one more thing I wanted to talk about. You brought up how Cartesian, the Descartes proved the existence of God because if God exists, he wouldn't delude us into believing false things. Well, that would lead to the Cartesian circle argument, which is the paradigmatic example of vicious circularity. So his argument didn't make a lot of impact because it was circular, viciously circular. So from my position, he didn't really prove God existed. That was the one thing that I really wanted to bring up at the end.
Well, that's not circular. It's just saying that he failed in that premise.
Well, it actually is. It's one of the proven standards of what circular reasoning is. It's a named circular argument, the Cartesian circle. You can just Google it and find the full page on what it actually is.
I mean, are you trying to argue that he? I mean, the thing is, it's the reliability of reason is going to necessarily be something that you can't prove.
Right, in a Griffiths lemma, it's always going to be unsupported based on circular reasoning, infinite regress, or dogmatism.
Yeah, you can't prove that one. So the thing is, Descartes didn't try to prove his ability to reason from God's existence. He took that simply as a premise. What he was trying to prove from what God wouldn't allow is the deception of our sense perception. The completely consistent deception of our sense perception.
Right,
which
and
his argument was not based upon sense perception being true.
Right, but that's the part that was circular. It's really complex, but I'd also like to hear your thoughts on that if you could take the time to research the Cartesian circle. That would be another thing I'd really be interested in hearing your thoughts on for next time.
Okay, because I can tell you I've read Descartes' argument very closely. It's not circular.
Oh yeah, I'd like to hear your thoughts on the criticisms of it, the analysis of the Cartesian circle argument.
Okay.
Awesome. Well, I really enjoyed our conversation. It was great to have you on. I really appreciate you taking the time out of your day to have a conversation, and I'd love to have you on again sometime.
Okay. All right. Well, thank you for having me.
Absolutely. Have a good night.
You too. God bless.